It is so wonderful today to connect with someone who impressed me so much the first time I met them. We don't just talk to professors and people who've been in the game for a long time. I really want to talk to a lot of the rising stars in the space sector and in science and in research. And everyone I spoke to before I met Laura just said she was amazing and she was a rising star and she's going to make a huge difference to the space sector. And I'm so thankful that you took some time out of your very busy schedule to come and talk to me today. Thank you, Laura González.
Thank you very much, Sam, for having me here. It's a pleasure to talk with you today.
Excellent. So you work in the space sector and you have done for much of your career. Can we just start with your journey? Was young Laura kind of looking at the stars and thinking someday I'm going to go there or launch things there?
The easy answer would be yes. But to be honest, I was a very curious child. I liked everything. I really liked space and I was curious about the stars, but I also very much enjoyed reading. I was reading all the time. I was very curious about everything that was going on around me. So actually, when it was the time to choose, I always tried to keep my doors open because I was very sad that I had to choose between, like engineering or the more like culture side of things, and actually I was doubting between studying history or literature and engineering, and at the end I'm happy that I chose engineering because I very much like the space industry, but in my case it's not something that since I was very little I had it very clear. And this is also a message to all of the people out there, especially the young people that are maybe not so sure about what they're going to do with their lives. I want to tell them that it's okay. I also had my doubts, and it was actually very interesting to go little by little discovering what I liked. And I think the more that you know about something, the more that you like it. So in my case, I studied aerospace engineering in my hometown at León. And something that really marked my journey there was a place called the Fab Lab. That is a laboratory, a fabrication laboratory where they have lots of 3D printers and CNC machines and a lot of equipment that you can use to do projects by yourself. And I found that very interesting, but not only because of the machines, but also about the community that it's around these places, that they help you. And I feel like you can create much better projects when you have a diverse team with people and now companies as well that can provide different insights and expertise in different disciplines. So that was definitely a highlight in my studies when I was at university.
So quite early on, were you needing to make a decision? Do I go into physics or sort of the sciences, or do I go into aerospace engineering? What was it that ultimately made the difference for you to choose aerospace engineering?
I guess that in between all the engineering, if we look around us, we always find engineering, right? Like everything is being designed and thought. And I found that very interesting. And then among all of the different engineering disciplines, I was actually fascinated by planes and how and why they fly. And I had the opportunity to study it in my hometown in León, which is a small city in the northwest of Spain. So yeah, I thought this might be, more interesting than the others. I was very interested in planes, and eventually I also found space and satellites there in one of the latest courses. But it was a little bit sad that we didn't get to space topics a little bit early on in the career, I guess.
Yeah, well, the space sector is huge now. I mean, it's booming, it's exploding, and there's so many opportunities. Talking to Patrick Rennie, he said, when he first wanted to get into space sector, there was only one route you could go, and that was defense. But now there's a whole lot more. When you were younger in high school, I'm thinking, I know Pedro Duque was a Spanish European Space Agency astronaut. I was talking to Michael Foale a couple of months ago, and he mentioned Pedro going to the space station while he was there. Were you inspired by sort of the European Space Agency astronauts to sort of pursue that line?
Yeah, 100%. Pedro Duque is a big figure in all of our lives in Spain. But I'm actually very excited for the next figures, the next roles that are actually from León. So we're a very small city. I mentioned it's 120,000 people, but actually two of the European Space Agency astronauts, both of them, they are from Spain. They're actually both from León. So now we're super excited in León, and it's been a big coincidence because, as you know, in the latest European Space Agency selection process for choosing astronauts, there were more than 20,000 people, and out of all of those, I think it was 17 different astronauts from the whole Europe. Some of them are career astronauts, some of them are reserve, and two of them, the two Spanish ones from Leon, like we couldn't believe it. I couldn't believe it when I heard. So I think this is actually a very good news for everyone, and it's going to be very inspiring for a lot of the generations that are now coming, especially girls. I think this is something very important, and we have an amazing advocate and ambassador for space that is Sara. Sara Garcia is our reserve astronaut. She's also from Leon, and she does an amazing job giving lots of talks and inspiring the youngest generations.
Well, there's something in the drinking water in your town that is producing a lot of space engineers and astronauts. How long
Yeah,
until
everyone
we
says
see
it's
you?
happening there, but I'm not sure.
How will you be a European Space Agency astronaut at the next recruitment?
I would love to. I did actually apply for the latest round. To be honest, I was a little bit young because they were asking for 3 years of experience, and I was only on my second year. But maybe in the next one, who knows? Yeah, I would definitely keep applying, and I would love to join Pablo and Sara. Actually, Pablo is a good friend, and I know they're amazing people, and I would love to work in this type of role. I think it's one of the best roles that you can contribute to society, right? Doing these experiments in space, also doing outreach when you come back. So I find it very fascinating. Yeah.
Yeah, I wouldn't bet against it at all. So what route did you take? Did you do a degree and master's and PhD, or did you go into industry straight away?
So I did my degree in aerospace engineering. I also founded a maker society while I was at university, and this was so that me, together with my friends, we could build some collaborative engineering projects, and we were working with drones, with 3D printers. We were building small robots, and that was actually very interesting, and I really loved being part of this and creating it and looking for resources and equipment for the team. But it also provided me with the opportunity to have a grant to study my master's in Madrid. So I moved to Madrid and studied my master's in aerospace engineering. And that was where I got the chance to study a little bit more in depth into space and space systems engineering. And I actually discovered that I really like those topics. And I had the chance to join a project that was between the university and an aerospace company. It's called Sener, that they do a lot of space projects in Spain. And we started working on a CubeSat project. So that was the first time that I was, hands-on working a little bit closer with space technology. And I really enjoyed it. I really like the systems engineering side of things, where you are coordinating the different subsystems and you need to know very well the technical part, but also trust the people that are on your team that are experts on, communications, power, and you need to make them all fit. I really enjoyed that role. So yeah, I did my bachelor's and master's in aerospace engineering, and a little bit later on in my career, I also studied an executive MBA. And only last year, I did as well a study at ISU, the International Space University. I was very lucky to go to Houston and study the Space Summer program over there, and it was an amazing experience.
Yeah, that's an amazing opportunity. I've heard a lot about that. So, I mean, we're all about polymaths here on this channel. So, you've got the business background, the engineering background. You mentioned robotics. How much does robotics and computer science come into play in your work?
Robotics and computer science, I guess that they have a big role, but not the one that I do myself. So in my current company, we do thermal analysis for space. So we have developed a software that is specifically for the space sector. And so computer science would be, 100% or 99% of the work that we do to be able to develop this software. And then the robotic side of things, I think, was a very important part of my start, because when I was at the Fab Lab or with the Maker Club, we were always working with Arduino, and you need the electronics to make all of these robots and drones work. So I think it's very important, is the basics. Perhaps my role at the moment is not so technical anymore, because it's true that I've evolved a little bit more towards the commercial side of things. So I'm the commercial director for my company, and I think it's important to have this technical background, but perhaps in the future you might not use it in your day-to-day, let's say.
Yeah, that's very impressive, and we'll get to your company, Radian, in a moment. You mentioned CubeSats. Now, I've seen CubeSats, but for the audience, could you just explain a bit more of what they are and why they're so popular and effective?
Sure. So yeah, CubeSat is basically a small satellite that can fit actually in a Rubik cube size, more or less, and it was developed to have a standard in the industry. It was developed actually in Cal Poly by a Catalan, Jordi Puig with other colleagues at the university. They wanted to provide the students with a tool that might allow them to learn more about satellites. But so far, satellites have been used to be very big technologies and not standardized at all, and very much one-off, right? So when you needed a mission, you would develop it only for that mission. With the CubeSats now, we have the opportunity to have a standardization. So we can have this cube size that is called 1U, would be one CubeSat that it would be 10 centimeters by 10 centimeters by 10 centimeters. And then this can allow you to have as bigger CubeSats as you want. So you might have a 3U CubeSat, a 6U CubeSat, a 12U CubeSat, but always with very similar interfaces and sizes, so that you can plug in different components. We actually call them components off the shelf, and you can literally go to websites like Amazon, in which you can find cameras, batteries, anything else that you might need to build a CubeSat. So at the end, this allows a lot of new companies, new actors, new players coming into the space sector. It's not only NASA or the big companies anymore. This revolution that we're living thanks to the CubeSats in the space sector allows this new space segment to come alive, and allows a lot of the universities and smaller companies to build and launch their own satellites. So I think we're very lucky that we have this type of technology, and I think it's changed a lot of what we do, because with these satellites we can do anything from navigation, taking pictures, Earth observation. There's many applications for this technology, and it also allows for more rapid development and a lot more iterations at a lower cost. So it's a tool that is very interesting for doing technology demonstrations and many other applications.
Yes, and now students and universities, as well as much smaller companies, can put things in space. I think the general public still thinks, when they think of a satellite, of like the Voyager and Mariner, sort of, really big ones with a huge dish moving through space, and it's really not that anymore. The commercial sector has boomed, and I look forward to getting into a bit more of that with you. But I first met you in England when you came over to work for Catapult. So could you explain how that happened, and then how you've gone on from there to start your own company?
Yeah, sure. So after I finished university, I started working at a place called INTA, that is the Institute of National Technology and Aerospace in Spain. And they work a lot with the European Space Agency. So I spent there 2 years working on systems engineering for space projects. And I had the opportunity to work in 2 science missions by ESA. So that was a really amazing experience. I got to be in the clean room, integrating parts of this satellite that is going to fly sometime next year. And when my internship there was coming to an end, I was looking for opportunities, and I've always loved working internationally and living abroad. So I was very lucky to find this opportunity in the Catapult, where they were looking for someone with experience in space and systems engineering in space, but also with interest in manufacturing. And I might have mentioned that I'm a little bit geek on 3D printers. I really love 3D printers. So when I was in the Fab Lab and then in the Maker Club, I was always playing. Even now I have a 3D printer in my shed. So I really enjoyed working with 3D printers, and I think in the Catapult they were looking for someone like me. So I was very lucky. I got to work with an amazing team. The Satellite Applications Catapult is an amazing organization in the UK that is supporting the UK space ecosystem, and it does that by supporting in the business side of things with a lot of experts that support companies develop their business plans and so on, but also, and I believe more importantly, with hardware and infrastructure. So, for example, we have vibration tables where companies can bring their satellites and test those vibrations before they launch them to space. we also used to have, we have like an environmental chamber where you can do the different thermal balance tests and so on. And in my case, when I joined the company, they were looking to expand the manufacturing capabilities. And I was very lucky to be there in the front row. And actually, they started trusting me and putting a lot of responsibility on me. So I was very, very lucky to have the opportunity to build a whole building where we installed some manufacturing equipment, including a metal 3D printer, which was, my baby, because I really loved it. It was fantastic to do all the, let's say, the procurement of the machine, but also the commissioning and then the operation. And we used to work with a lot of the companies in the UK, mostly with propulsion companies. And we were using this 3D printer, the metal fab, to build rocket engines. So yeah, it's like this size rocket engines, mostly for in-space propulsion for satellites to move in space in different orbits. And yeah, it was fantastic because that same machine, the metal fab, was the same one that SpaceX has in the other side of the Atlantic. I think they have 15 of them. So yeah, we only had one, but we were doing the same type of technology, right? We were doing metal 3D printing of rocket engines. And I think that's fascinating. And I have great memories of I think it was over 3 years that I spent in the UK working in Oxfordshire. So the Catapult is based in Harwell, which is where the main space cluster is in the UK. But we also had a facility, and the manufacturing side was in Westcott, which is a little bit north from Oxford. And that's where I was working for all that time. Yeah, it was fantastic to meet you then, Sam. I remember that we went to give a talk, and I think this is something that I try to keep doing and try to keep going to schools and inspiring the younger generations, because I feel like they have an amazing opportunity in front of them, and we need to encourage them for sure.
Yeah, I think all of my students wanted to immediately leave and join the space sector just by the end of that. It was really incredible, and it blew the teachers' minds as well, because I mean, science communication is good and it's improving, but you often feel like, particularly with the space sector, the rate at which it's progressing far outweighs the communication to the general public. So, I mean, I doubt the average person on the street really knows that you can 3D print rocket engines in space. That's incredible, absolutely incredible. So, tell us about Radian.
Yeah, so Radian was started actually in 2019. So when I was finishing my master's, I found this team of amazing people that were developing this software as part of, let's say, the university findings. When we were at university, we realized that there was a small gap in the market because the current tools to do this thermal analysis, it was very difficult to use. Basically, when you have a satellite and it's orbiting around the Earth, when the sun hits the satellite, the temperatures are very, very high. But when the satellite is in the eclipse, in the shadow of the Earth, the temperatures are very, very low. So the engineers need to be able to predict the temperatures and simulate what's going to happen in the future when the satellite is in space, so that we can improve the design and we can make better designs that can resist and survive the temperatures in space. So thanks to our software, we have a cloud-based software, and what it allows is the engineers to do these calculations much easier in a much more intuitive way, so that they can redesign the different satellites and the technologies so that it's improved before it's launched to space. And so, yeah, we started the company in 2019. I was working, let's say, my weekends and, my free time as I was at INTA and then at the Catapult. And at the same time, my co-founder, David, who's the most technical person, was working in the development of the software. And it got to a point last year in 2024 when it was already time for me to move on and focus most of my time in Radian, because we had already scaled and the software was already very robust. So we needed the commercial side to give a push, let's say. And we're now super happy because there's been more than 60 satellites that have been launched to space over these years from 2019. And we have around 17 customers in 8 different countries countries. So it's something that it's growing. We hope to, get to more users and help many more engineers. But we're very happy now, and yeah, it's a fantastic journey. And especially when you talk with the different users, and they're super happy, and they say, "Wow, this is so much easier than what I used to do before." Yeah, you really feel that you're making a difference. So we're very happy.
Yes, and I mean, it's going to strike a lot of people just how young you are and how dynamic you are, and what you've managed to achieve already in your career. Um, for young people who want to get into the space sector, and particularly the commercial space sector, or adults looking for a career change who are interested in this, maybe they're geeky about it, like you and I are. What would you recommend in terms of working in the commercial space sector?
I always recommend to be curious and stay curious. I think curiosity is one of our biggest assets when it comes to science in general. If we're talking with smaller and younger people, I would say that don't get scared. I feel like space can be for everyone. And it's true that the engineering path is the most typical path. But the good thing about space is that we need everyone. We need the engineers, but we also need the good communicators, as you were saying. We need space lawyers. We need all of the different types of disciplines. Even when we go and mine asteroids, we will need that mining expertise, right? So I think anything that you study or whatever you're curious about, if you pursue it, and if you want, you can always orient it towards space sooner or later. If you want an easier path towards space and you're a geek young person and you like engineering, I would definitely recommend to study science and technology and engineering. I think it opens a lot of fields, and perhaps after studying engineering, it's easier to move sometimes to other type of roles, like myself at the moment. And I think now there's a lot of tools, and I'm actually a little bit yellow sometimes because I wish that when I was younger there was things like the Lego League, like you can build these robots now with Lego that didn't exist when I was little, and I found them amazing. But also there's things like 3D printers now. With 100 euros or 200 euros you can buy your own 3D printer and it works, right? The ones that I started working with didn't work. Like I spent most of my time trying to fix them. So I think these type of tools really help. And if you're a young person that wants to go into engineering, I think playing with this type of equipment is actually going to help you. And I think you're going to have a lot of fun in the meantime. There's other projects like the CanSat. I don't know if you've heard of CanSat competitions, but those I really like. So it's basically replicating a satellite in a can, like a Coke can, and they put there all the different subsystems and even a payload. And so there's high school competitions in which you get together with a team from your school and you do this type of projects. And then at the end of the design and after you build it, you actually go and launch it with a rocket. So there are different initiatives all around Europe. I'm pretty sure there's also in the UK, and it really relies on, like having students that are proactive and want to be part of this, but also sometimes of mentors, teachers, even parents that are supportive and can give them a hand. But these type of projects, I find they're amazing. If you find that you have a Fab Lab or a maker space around you, I would really recommend to go and visit, because this can really help with your engineering skills in general. And thinking of young, like more adults, let's say, that want to do that career change, I would really recommend the International Space University. I think that's where this program could be the most helpful, because it really provides you a very interdisciplinary view into the space sector. So you have engineering classes, but also policy classes and master classes that are actually given to you by astronauts or by NASA directors. So you're there and you're like, oh my God, like I remember some of the classes about human performance in space and human factors given by one of the Canadian astronauts. And it's like, seriously, like goosebumps when you listen to that. So I think it provides you as well with a very nice network of people, and you become part of this bigger family that can help you find a job in the space sector or get some advice on your career. And it's truly a really fantastic experience because you're there for 2 months in this university, or usually it's in a student campus. The good thing is that every year it changes location. So last year I was lucky to be in Houston. This year is going to be in Korea. And so every year it changes the location. And you're there with other space geeks or space curious people like yourself. And you spend, the breakfast, lunch, dinner, all of this. And then there's lots of projects. So you get to know a lot of people and really connect. So I think the International Space University is what I would recommend for adults that want to change and move into the space sector.
Well, that's incredible advice. I just wonder. I would like to ask you about space debris, if you don't mind. If it's not something you're very involved with, feel free to say. But I know that Catapult were quite involved with it. You mentioned launching 60 satellites already through partners you've been involved with, and people see so many more missions to space happening. I mean, I looked at the list yesterday of all the launches that have happened this year, and it's staggering how many launches across the planet have happened this year. And there is a concern. I mean, anyone who's seen the film Gravity with Sandra Bullock, worries about space debris. What are your thoughts on this? And are there realistic things that can be done to mitigate the problem of all the debris, especially with how small CubeSats are, and all the Starlink launches? How much of a problem do you think it's going to be? And are there realistic things that can be done about it?
Yeah, it's something that I'm not an expert, but I think everyone in the space industry is concerned and is aware about this increasing problem. It's true that, the more satellites that we launch, the more opportunities that we have, but also it can be dangerous, right? Space is a pretty big space, but still, if one of these pieces of debris hits another one, then we can get what we call the Kessler syndrome. That means that one will imply that will create many more debris, that will create many more debris. So it's very important to be able to have a very clean environment. And I think that's where we have a lot of different initiatives by the European Space Agency and others. And one of the most important things or that we can do at the moment is to make sure that these satellites, once they're launched, they get outside of the usable orbits once they finish their life. So at the moment, the most of the guidelines from all of the countries that allow launching satellites to space tries to make sure that they will deorbit and they will re-enter the atmosphere. They will burn in the atmosphere in 25 years after they finish the lifetime. So some people think that this is a very long time, that we need to make sure that this is shortened. But I think this is where space policy comes into play, right? At the moment, we don't have a space police or anything that will make you accountable for this. And so this is one of the problems. And the good news is that we also have companies that are developing solutions. So, for example, Astroscale, ClearSpace, there are different companies that are already developing solutions and doing tests. And there's many different ways to try to clean up this debris, right? From having big nets that would take these satellites and then bring them down. There's harpoons to try to grab them. There's many different technical ways to do it. The main problem still remains on the business plan, right? Like, who's going to pay for these companies to go and clean up the orbit? So that's one of the biggest challenges. But I think we're moving little by little in the good direction. We have policies in place. Everyone's very concerned. And if we all want this space economy, this space ecosystem to keep being, important and vibrant, we know we need to also take care of it. So I think everyone's very concerned and aware of this.
That's great. I'd love to ask you about the human spaceflight side of things. We're seeing more missions with Axiom, and there seem to be more, particularly short-term opportunities for commercial astronauts coming up. How do you see the future landscape of human spaceflight, and what are the things you're excited about or hopeful for?
I think we have an amazing future in front of us. I believe the first person to step on Mars has already been born, and it might be, in one of the classes that we go to give talks to. So I think we have an amazing future in front of us. These private stations and private commercial missions, I think, are actually contributing towards the effort of humanity. I think it helps a lot because all of the technology needs to be developed, and the more competition that we have and the more companies that are involved, the fastest this technology is going to be developed. So I think they really help. I know there's a little bit of controversy with the role of these commercial or private astronauts, but all of the ones that I know, they go to space to do science, right? So it's a different path. Of course, a more official path through ESA or NASA is what we're all used to. But I believe that this is not in detriment. I think this is going to complement and support in a private way, similar that it has been happening with companies like SpaceX or other companies that we've seen that has actually developed and pushed the technology development in many fronts. So I'm very excited. I think we have a very exciting future ahead. I think there's a little bit of doubt in the next years. We know that the International Space Station is going to be decommissioned, and that's going to open up a lot of opportunities. And we will see how it shapes, right? Because I feel for a lot of us, the International Space Station is an amazing place, not because it's the biggest thing ever constructed by humans, but mostly because it's the place that for me represents the cooperation between different countries, right? So once this comes into an end, we will see a different landscape with not only different countries, but also now companies that will create these commercial space stations, which I'm very hopeful for, but also I'm worried that if it doesn't have this cooperation spirit, it might not be as good as it should. So I'm very excited for see what's happening next. I think we have a lot of opportunities, and it's gonna be great for the all of us at the end, because all of this technology that is developed for space at the end comes to our lives and makes our lives easier. And so I'm very excited about all of these investigations and science that is going to happen in space.
Yeah, I really can't imagine life without the International Space Station. I mean, it's been there for most of my life, and it's been an ever-present. I say to students today that there hasn't been a day since the year 2000 that everyone has been on Earth. And that's been their whole life, their whole experience. Do you know much about the commercial candidates to launch space stations are, where they're at, and how soon that might happen?
I'm not an expert. So I know there are different commercial, let's say, partners that are creating these stations with Axiom. We have many different organizations, but I wouldn't like to talk about something that I'm not an expert on.
Yeah, that's fine. Wondered if you know. I'd just like to finish by asking you about other things that people might not know much about that are in the space future, the future of space flight, looking at the next 30 to 50 years. You mentioned mining asteroids. And I mean, I thought the landing on an asteroid was one of the most incredible things I'd ever seen a little while ago. But, that's one example, and you feel free to speak into that. But what other things do you see on the horizon, either practically or hopefully, in the future of spaceflight?
Something that I think we're already seeing happening, and the Catapult is playing a big role, is what we call in-orbit servicing, assembly and manufacturing, or ISAM. There's actually, at the moment today, there's a conference in Belfast that the Catapult is organizing with the UK Space Agency. And I think this is a big topic because we're seeing how we're developing a new economy in orbit. So before, most of the market was focus regarding satellite applications and how we can have a business around that. But now there's more and more services that imply a company in space providing a service to another company in space. So this is something that is changing the paradigm. And we can see how, for example, a company might offer to extend the life of another satellite by bringing kind of like a backpack with extra power or extra fuel. And this is something that was not done until now, right? With the satellites, you launch it, it does their mission, and then once it ends their life, it needs to re-enter in the atmosphere, or it's put in a cemetery orbit farther away where it doesn't bother anyone. But now with these new services, maybe we can refuel these satellites and bring, to a petrol station to continue using them, or we can do things like assembling things in orbit. One of the concepts that the Catapult used to work a lot on was the space-based solar power. This is like super huge platforms, right? And in order to be able to have this super, super big infrastructure in space, we cannot just take it there. We actually need to deploy it, or we need to be able to manufacture it, to assemble it in space. And so these are things that haven't been done yet. And they also require a big effort and a very technical development, because there's a lot of things regarding the inertias. Once you approach another satellite, there's a lot of physics that happen there that we're not very sure how to model. So I think this is going to be something that is very big. And I'm particularly excited about the in-orbit manufacturing. I think we can make use of the environment that we have above our heads, and these type of developments in which we use, for example, the microgravity to grow organs or better crystals or cells in a way that they don't collapse because of gravity, but they can actually grow homogeneously. I think this is particularly exciting because it will allow us to produce materials that haven't been developed on Earth yet, or certain products that have better quality when done there, which is not only useful for the astronauts themselves, but also for us on Earth. And we can bring all of these high value items back to Earth, which I find fascinating. And of course, when we go to the moon or Mars, we might need to build our own things there, right? So 3D printer or manufacturing in different locations will be also very, very exciting. Exactly. Yeah. Exactly. We need everyone. So I encourage everyone to look for your ways into the space sector. And yeah, let me know if you need anything. Thank you so much, Sam, for today. Thank you.
Thank you so much for watching. Don't forget to like and subscribe. Stay tuned for more amazing conversations with incredible researchers who are changing the world we live in and driving humanity forward. Feel free to check out my Instagram at polymath_Sam, or go to my website at www.sam-mckee.co.uk.